Hi, this is Brian Long. I'm a freelance trainer, troubleshooter and consultant who works with Delphi and C++ Builder among other tools. This session is a little introduction into debug logging in FireMonkey apps with C++ Builder. When debugging an application, there's nothing more valuable than evidence in order to assess a situation after the fact or indeed during the fact. And so what we're going to be looking at is the opportunities that FireMonkey avails us of in order to manufacture this evidence via simple log statements. What APIs do we have to log information in a FireMonkey application? The first option that presents itself is one of FireMonkey's platform-agnostic platform services, in this case FMX logging service. The general notion is you inquire whether a service is available, and the logging service is available on all supported platforms. You get a reference to it, you call one of its methods. In this case, the log method has exactly the same signature as the runtime library format function. Here's some code that uses the FireMonkey logging platform service, and whilst it's perfectly usable and perfectly functional, and it does what it needs to do, it is rather more verbose than is actually necessary. And so whilst it is an example of platform services in use, that's all I'm going to say on the matter, and we're not going to look at this code anymore at all. The reason being that platform service calls down into another piece of FireMonkey behavior, another piece of platform agnostic behavior implemented in a class method in the FireMonkey types unit, a class method D of the class log. So log D gives exactly the same behavior as that platform logging service, which simplifies the code down to this. Log D has a variety of overloads that you're at liberty to explore at your leisure. The more important question is, where does the output of log D go? Where do these debug strings go such that we can view them and assess the progress of our application's execution flow during its run? And the answer is it depends upon various factors. For example, the target platform. In the case of targeting Win32 or Win64, the application's debug strings will be displayed in the debugger event log. In fact, let's just prove that point by running up the application. Here is the event log down here. Here's our application, and when we induce some debug messages, then sure enough those are reflected as debug output lines in the event log, assuming all the properties of the event log are at the default. And this is because the event log, or the debugger, is looking out for certain Windows API calls being triggered, and in this case what we're talking about is the API that log D calls when running on the Windows platform, and the API in question is output debug string. The debugger picks up the information passed to output debug string and displays it for our delectation in the event log. So that's all good for Win32, Win64 and running inside the debugger. What about not running in the debugger? Is there a way of picking up the debug strings then? And yes, there is. There is another tool, a great little tool called Debug View, which comes from sysinternals.com, which is a redirect into the Microsoft website. Debug View is a free tool which will do much the same job as C++ Builder's event log will, which is to display debug strings as it finds them. So let's prove that point also by running the application outside the debugger and seeing that, sure enough, we do get the debug strings being displayed in Debug View. So we've covered the basis of Win32, Win64 being debugged, not being debugged. That covers those avenues. What about the other permutations? What about the other platforms? Having dealt with Windows targets, let's now move on to a mobile target, this time Android. Android comes with an SDK chock full of tools, most of which, as C++ Builder developers, we need not pay any attention to. In the case of logging, however, there is a tool, well actually there's a pair of tools, although one of them has been deprecated, with which we can see logging output. In Android terminology, all of the logging output from all of the applications and system services running is called logcat, and we can get the logcat output displayed on the command prompt or within a terminal, but it's not particularly manageable or workable in that fashion. So generally speaking, we use a GUI tool. The original GUI tool was called DDMS, or the Dalvik Debug Monitoring System. That's been deprecated and replaced with Monitor, which does the DDMS job as well as some other jobs as well. So how do we find the Android SDK tools? Okay, it's actually easiest to do this from within RAD Studio. So if we bring up the Tools Options dialog, and move down to the SDK Manager and select the Android SDK, you can see the base installation path sat there, and in fact you can see that it's actually installed within the shared public documents area. So let's copy that path out of there. We can paste that into a copy of Windows Explorer, and that takes us to the installation folder for the Android SDK. From there, navigate into the Tools subfolder. There you can see the original and deprecated DDMS tool, and you can also see the replacement and active monitor tool. So let's get that up and running. There it is. Okay, so when it pops up, we need to make sure that the DDMS perspective is active, which it is, and then all the action occurs in the Logcat tab. So let's make sure this tab takes up the majority of the screen here, and then we can see all of the debug strings being pumped out into this Logcat window. And this is where the output from our calls to logd will also appear, and you might therefore see, given the speediness of the stream of information going through it might be a bit tricky to keep hold of where our messages are within this Logcat. And that's where the filters come in. So I'll set up a little filter here, such that only debug strings emitted from my application, those applications which have a package ID starting with comblong, satisfy the filter and will appear in the list. And that gives us ostensibly a clean sheet. Generally speaking, it will be a clean sheet. Back in Rad Studio, you can see here that I've switched to an Android target, and I've also got the package prefix as specified before, com.belong. The default is com.embarcadero. So now we're ready to roll. Let's get this puppy up and running. With the magic of video editing, that's now up and running on the device, and if I press the button on the screen, the same application that we saw as a Windows target, there's nothing appearing in the event log inside the Delphi debugger. However, if we pop over to the Android monitor, you can see that every time that I press the button, you could probably hear that in the background, an extra entry is added into my filtered Logcat. So that sort of kind of wraps up the whole Android side. For iOS applications running on iOS devices, i.e. iPhones, iPads, then in order to reveal the logging information, the debug strings that we're emitting via our calls to logd, or indeed the FMX logging service, then we need to go into the world of Xcode and find the relevant tucked away corner which contains all of this information. So there is a console of a logged output available from Xcode, one for each device. Let's go and find it. Here we have a copy of Xcode. What we do is we go to the window menu and choose the devices window. This gives us a list of all the available connected devices. Oh, apparently there was some error on my phone, never mind. It gives us a list of the installed applications, and in addition there is a tiny little triangle that you may well overlook, but if you do hover over it, it gives you the indication that there is a device console available. So if we click the triangle, it inverts and unveils this device console. So I'm going to launch the application that I've got running on the phone and press the button a few times, and as you can see, the log information is sent over to this console view. So that is what it takes to see logging information coming from a live application on an iOS device. Finally, we have macOS or OS X applications to consider. The implementation of logd on OS X is not done using the same underlying API as it is in iOS. For iOS, the nslog platform API is used to send the information to the relevant console pickup. In OS X, logd instead is implemented by a simple call to writeline. So basically the information goes out to standard out. So how do we pick that up? Okay, let's have a little look-see. Here's our little testbed application running alongside PA Server, the tool that invoked it in the first place. Now, because it was invoked from PA Server, and PA Server is essentially a prompt, a terminal window, a command prompt, then what happens is we press the button and the logging information gets dumped out on that command prompt. So the PA Server window is where we need to be looking. Okay, that just about wraps up the session, so thanks very much for attending, and I hope that's been of benefit. Thanks very much.